where I taught Spanish at this fine institution in Elk River. And I'm back there now. I went to College of St. Catherine, that's down in St. Paul, a four-year degree in what we called quantitative methods. That was the old school term before they decided to call it computer science. It used to be that you could get into computers with a math degree or a music degree or anything that had sort of a mathematical sense to it, but now you really need to have a computer science degree. I also went to a couple of schools to learn to speak Spanish, and I have not used Spanish much in my engineering, but I have entertained people from other countries when they come to visit, so that's nice to be able to do that. Can you give me a quick down arrow? Yep. Okay, thank you. Okay, so what does Unisys do? Well, Unisys is a computer programming company. We provide computers, and these are three goals or focal points that we as a company do. Mission critical is a big word that you'll hear. It's another way you might hear it is 24/7 access. Because the world doesn't go to bed at 10 o'clock anymore, the world keeps going, it's global, and if you run a business in Elk River, people may still be buying from you in the middle of the night on the other side of the world. So mission critical is important. Places that have mission critical software that Unisys works for are banking. I myself have been working on Lloyd's Bank in London, making sure that they are up and going all the time. If they should go down, the system, the computer system go down, Unisys will often incur a penalty because while they're down, they lose goodwill, they're unable to transact business. And so being a 24/7 mission critical piece is important for our customers. Airlines are another one. If your computer system is down, you can't schedule your cargo, you can't schedule your passengers, you can't purchase a ticket. So these things are all important parts of what we do at Unisys. Now, computing is much larger than just Unisys. I'm just telling you about my life. We also did the Olympics. We're part of that broadcast and scoring and keeping track of everything. It was, I forget what year it was, within the last 10 years. Telefonica in Spain uses our computers to keep their telephone software going. Now, stealth is a new thing. Because we hear in the news about theft of data at, let's say, Target or someplace, this is a big and up and coming thing. Our less savory people are becoming more educated and able to break in, especially with the cloud computing and things being done on the web rather than a little private box that I can physically control. So how do we control things when it's all out there on the web? This is another piece that Unisys is breaking into with our stealth program. Why is that important? Well, if you're in a bank, let's say Lloyd's Banking or any financial organization, you don't want people stealing your data. Or if you're a large department store, or any of the other recent things. Government, if you have some kind of personal data, medical is another one, people's medical files, mental health files, you don't want those compromised. I say I have finance there twice. And then forward is the next thing at Unisys. It's integrating things so that users can be fairly simplistic and not have to think about how everything works together. Because back in the day, we had these computer nerds that could do anything, and you would go to the guru and say, oh, please help me. But now people are becoming more participative in managing their systems, so we have to make it easier. So these are our three core thrusts, and I'm involved with all of these in some way. Okay, so what do you make if you are an engineer, a computer engineer? It's not that simple to just tell you exactly what you'll make, because it's more of a formula. Okay, so types of engineering or computer software you might write. You might write simple programs like a phone app. Okay, something very small and limited, and maybe it's just got a couple of thousand lines of code. Or you could go all the way then up to a banking system where they have to be concerned that if they withdraw from this account and something interrupts it, that they don't lose that money before they deposit it or put it back in that account. So things that could interrupt, a power glitch. That kind of programming is extremely complicated. And so that would demand more money. And the other thing is, how many people can do what you do? Okay, so if you're just a simple Java programmer, everybody knows Java anymore. The way I got my job back at Unisys is because I could write assembly language. Nobody writes assembly language anymore, but I do. I recognize ones and zeros just fine. And so that got me that job back. The company that you work for, some companies are startups. You might get paid more or less depending on the kind of financing you have. Some are global and have a lot more money. My son works for Accenture. I don't know if anybody else does, but boy, they seem to just be having a lot of fun with their money lately. So depending on where you work, the kind of industry, you could have more or less. How long you've been there, you'll see that on the pay scale. If you're just a beginning engineer, you're not going to command the same kind of stuff for someone who's got a PhD and has been around a long time, knows how you do business, and knows your customers, and knows your product. Another reason why I was able to go back in is because I knew the business of Unisys. So I was able to go back in because of my length. The quality of the work, no matter what you do, and how you do what you do, affects what you make. So while you're thinking about your homework, guys, right here in this building, the quality that you put in here makes you the kind of person that gets the job done for your company later. So don't slack. Get your Spanish homework in. All right. And the economy also makes a difference as to what kind of money you make. At Unisys, when I first began in '82, which is years ago, raises were everywhere. But someplace in the sort of the 90s, things kind of took a pike, and then we had this lowering, and then we had layoffs, and so we all do much more than we used to do for about the same pay. So let's look at the scale then. So now you've got an idea that it's not just a fixed thing. Now what I did on this is I looked online to find this snapshot. I looked at a number of them. This is actually Unisys people. They register their job title, and then you can see what they make. So let's start here with a software engineer, which is what I began as in 1982. Okay, so actually I made $25K in 1982, but today that same job, the low pay would be 40. And they can go up to 86, but that's saying that you would never get a promotion. You promote down, and now here, software engineer, senior software engineer, lead software engineer, they're going to be making, at the low level of a low performer or someone who's in a repetitive job that anybody could do, they would make 65. But our top engineers, our consultants, the people that own the knowledge, the thought leaders, they're making up to like 130,000. And this, I'm sure there's outliers all over the place on this. All right, so let's go ahead then. All right, it's kind of a bad picture. You can't see it much, but what I'd like you to think about is what goes into programming. A program is simply a bunch of instructions to do a repetitive task. If you're playing World of Warcraft or whatever the hot game is these days, it's simply if he pushes the down button, then do this. If he pushes the down button and the alt is on, then do that. Else do this other thing. Okay? So it's very simple when you break it down, but you have to add lots and lots and lots of these. I work on an operating system with 4 million lines of code. Of course, I don't write all of those lines of code. I write a small amount of those lines of code. I'm an expert in what I do. Okay, so here's the big picture of how the software development process works. We have a number of kinds of engineers. First off, we have engineers who are the big thinkers, our thought leaders. They say, you know what, I think our customer would like that. Or the customer himself says, you know what I'd really like is one of those. And then we get that input. We study it, we decide if that's reasonable to do, and then we say at the end of it, what will we do, how will we do it? What we will do goes to our technical writers. Yes, writers can be engineers too. They have to understand technology, and make it accessible to everyone who's going to use it. So they would get the what, and I would get the how we're going to do it. I want you to do this program, I want you to do it in this way, and I want you to do it in this impossible time frame. Okay? And that's my job. All right? So rarely do we work individually as engineers. As I listened to all of our other engineers here, I passed that on to the mechanical engineers. Then we would ask this engineer. We are a group. If you can't get along with people, you're not likely to be lasting very long in the engineering world. You need to develop those soft skills of compromise and getting along, expressing yourself, being clear and succinct, sticking with the game. Okay, so that's what we do here. Somebody will design it. Somebody will then look at it. I can't just go off in my own world and go until it's done. I need to have someone look at it and say, yep, I think what you wrote is good, but have you considered what might happen if this went wrong? Oh, okay, I thought of that. And then we add that in. Okay, so we're always a team. Then I would do the code. Once we agree on how we're going to do that, I'll code it up. And again, then, my coding gets inspected by someone. It's always someone being like an overseer. But then that same person, I would oversee their work. All right, and then we'd make a plan. How am I going to prove that this works? How will I know that this addition, this extra set to World of Warcraft will work? Well, I think I'd probably send it to Avery and have him play it for a couple hours. Okay, so he would be my test plan. Okay, and then Avery would execute that test plan, and he would create a list of problems for me. That would be up here, a comment form or a feature suggestion. You know, it would be really great if you had uglier monsters. These monsters are way too friendly. And so then we would handle that. All right? So then we would pass it off to our client. Now here's another kind of an engineer that you might be interested in. The client has to interface with the big Unisys company. Well, who are they going to call? The president? No, that doesn't work. So we have field support engineers, and they're technical enough to be able to understand what the customer's saying, and then they contact us directly, get the big detailed thing, and then they soften it up to pass it out to the client. And then sometimes, if your organization is very large, you might have that tester. Here's Avery right here. Okay, he tests engineering, he figures out how to do it. Now, this is a big company. If you're in a small company, you do all of this. Okay? And on some projects, I'm doing all of this. But on other projects, I work as a team. Okay, so let's see, did I cover it all here? I think, do I have any more? I think that's it for the slides. Let's see, I looked a couple of things up too. The average, what you saw was Unisys. The average computer engineer gets $93K a year, which comes down to $45 per hour. However, I'm not going to tell you how many days I work an extra couple of hours, or I think about it on Saturday and go sit in my office and do a little something. Okay, that's what makes me a standout, is that I do the extra. Okay, and then at my desk here, I've got a few things. This is a little handout that you can take with you about what kind of person does each of these jobs. And then I actually have something from the career fairs where we welcome college students to, as they're graduating, to come and apply at Unisys. This tells you what they want, not just can you write Java, but it's very important that you can have the soft skills. Let me just read two of them here. Team player, collaborative, self-starter, has initiative. Those are things that you can be developing way before you learn how to program. What do I like about my job? I like a lot of things about my job. I like the silly, wry sense of humor that engineers have, because it is really special. Okay? I like that I can finish something. I like finishing something. The feeling that you get when you give your code to the people who build the code into the big system, and then you see it working at someone else's desk, that's a really great feeling, because it was your idea, and you babied it, and you launched it, and now it's out there. It's a very cool thing when you have a product that you had a part in. Paydays aren't bad either.
All right, so that's all I have speaker-wise, but now we have about 10, 20 minutes to have some Q&A time. So if